1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And by the time you get here, you're starting on a new octave. And an octave would be a set of 12 notes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And you'll see we have a set of 2, a set of 3. The set of 2 and set of 3 make up a greater set that encompasses, if you wrap your fingers around them and then drop them on the outside, that encompasses an entire octave of 12 notes. And you have black notes and white notes. We're going to cover the black and white notes. Let's look at the diagram. So we showed you the 12 chromatic notes. And some are white and some are black. Well, you see the shape inside? This is a 7-sided shape. From C to D to E to F to G to A to B and back to C. 7 sides. 1, 2, 3, 4, 5, 6, 7. 1 side, 2 side, 3 side, 4 side, 5 side, 6 side, 7 side. And those notes represent the white notes from C to D to E, F, G, A, B. C, D, E, F, G, A, B. And look, our black notes, wrap our fingers around, and we go from C to B. And then up here is the next C. If you go to the next C, you're actually counting 8 notes, but you count 7 because the next C is actually a redundancy over this original C. So you have octaves. You know, the piano has 7 octaves. 1, 2, 3, 4, 5, 6, 7, a little extra. And each octave from low, the lowest ones sound low, and the highest ones sound high. It progresses evenly from low to high. And each note from here to here is an interval, and then here to here is an interval. Even from here to here is an interval of an octave. From here to here you span the interval of an octave. From here to here you span the interval of just one note. Here to here you span a whole note, and this one will be considered a half note. So there are intervals possible even between here. This is the interval the piano gives us. But if you had a guitar or a fretted instrument, you could work shorter, smaller intervals than this and end up, you know, with more note possibilities. But for now, the piano only gives us 12. You know, if you had a open fretted instrument, you could fit in 24. Eventually, you can only have so many intervals before the human ear doesn't really pick up the differences. And likewise, if you go too low with octaves, it's hard to pick up the, you know, distinguish one ultra low note from another, and eventually they get so low that you can't hear them. And then same thing with up here. They get so high that you can't tell one note from another, and eventually it gets high enough and you can't hear it. You know, maybe your dog will, but not a human ear. So the 12 notes, and then the white notes, that's the major scale, and that's what we've drawn up here. This 7-sided shape is the major scale, and it's taken out of the chromatic scale. When we take out the 7, when we take out these 7 white notes, we're left with only the 5 black notes. And guess what? 5 plus 7 equals 12. We took 7 away from 12, we have 5 left. But it's not just as simple as doing simple arithmetic. There's actually a reason why it's these 5. Why can't it be 1, 2, 3, 4, 5? These 5 left over, and we just take out 1, 2, 3, 4, 5, 6, 7. We take out these 7 and leave behind these 5. There's a reason why we take out these 5 in this distribution, this spacing, this positioning. It's all about distribution, which allows spacing, and then eventually it's about the geometric sequencing. These notes belong to a sequence, and this sequence belongs to a geometry that translates to a shape. We draw out note for note from C to D to E to F, just like we do note for note, C to D to E to F to G to A to B. C, draw a line to D, draw a line to E, draw a line to F, and then you start to see this symmetrical shape. Look at that. It has a line running right through where the symmetry is. And on this side, it's a mirror image of this side. You could literally fold it over like a butterfly, two wings mirroring each other. That's what's going on in what makes harmony, and that's what's behind the melody of the scale. And so this line of symmetry. Now the interesting thing is that this note strays outside of the boundary of the scale. So we have the 7-note scale, and then we have the line of symmetry cutting through the D, and then including the G sharp. Why does the G sharp get to join the party? I mean, it's good music and all, so but why don't the other ones get to come and join the party, enjoy some good music? Why the G sharp? Well, it happens to be along the line of the symmetry, and the line of symmetry is where it happens. It happens within the bounds, the selected notes, and anything that falls within the line of symmetry. Some scales, some chords, you can get the line of symmetry falling only within the bounds, rather than straying out. But this one brings something else into the picture, and there's good reason for that. You want to use relativity as far as what notes are in common within the scale when you decide chords and other scales for composing music. You want to build your chords out of the notes that are within your scale. But what happens when that gets old? Those black notes are going to be there, and they're tempting. And these are all the sharps and flats. They tend to be, you notice we have a B, C, D, E, F, G, A, and the ones left out that aren't included, there's a B flat, there's a C sharp, E flat, there's an F sharp. All the sharps and flats are left out. But this one sharp is included by proxy to the line of symmetry. And that line of symmetry actually gives it harmonic significance. When you go ahead and include it with what you're playing, it has harmonic significance. We're going to get into that as we move into chords. But you can see the scale, its function is relative to its geometry, and its geometry is built for the function of symmetry. So that's what's going on in harmonics and melody in music theory. Now down here we have that same scale, C, D, E, F, G, A, B. But then we have a chord plotted in this dashed line, dotted line, dashed line, and that's the A, C, E. And then we have another chord plotted in regular line, and that's the C, E, G. Now, did I already mention that this is the C major scale, but it's also the A minor scale? And I'll show you why. Because the C major scale has these notes. All the white notes make up the C major scale. Well, here's the A minor scale. All the same white notes make up the A minor scale. They share the exact same notes, and not only do they share the exact same notes, they share the exact same shape, the exact same distribution of the notes. The geometric sequencing of the notes is exactly the same. They say that the C major scale has a relative minor scale, and that relative minor scale is the A minor scale. And saying that it's a relative minor is putting it loosely. If you say that they're one and exact same scale, only difference being that you start on that exact same scale at the A point to define an A minor scale, but then that same exact scale, if you start at the C point, you've defined a C major scale. So they're one and the same scale, just the starting point defines the scale as whether it's the minor or its relative major, or whether it's the major and its relative minor. We tend to say major to its relative minor. But if you're starting off at minor, then you want to consider its relative major. Now, when we come down here, we plotted an A minor chord and we plotted a C major chord. And the reason we plotted both those chords is because from the C major scale context or point of view, the C major chord is the primary chord for the C major scale. And then from the A minor scale context of this shape, the A minor chord is the primary chord for the A minor scale. So if you look, even when we plot the chords, A minor overlapping this way, C major overlapping that way, and they both overlap that line of symmetry. To give respect to the line of symmetry, they overlap each other in a symmetrical way that gives respect to that line of symmetry. So still we see that line of symmetry being maintained. Now each chord by itself, the A, C to E, it's not really symmetrical. They don't have any sides that are equal. You can't draw a line of symmetry through it anywhere. But when the A minor overlaps with the C major chord, they overlap in a way that, you know, outlines or highlights the symmetry of their parent scale. Now, I tend to consider the chords that there are only 4 chords, and even so, you could say there's theory that can show that there's only 1 chord, that you could say just the major chord, and the major chord includes interval for that, interval for that, and interval for that. So you got 3 chord interval options that you could relate to the major chord, and then all other chords are expansions or diminutions of that. The A minor chord is the second type of chord, but they would say that that's, well, the minor is, for instance, if we have a C major chord, the C minor would simply be taking this 3rd note in the scale progression and dropping it down. So the difference between C major, which is this, and C minor is this. So you could say the C minor is just a C major that you've changed by 1 note. And here we are with the A minor, and you could say that it's A major that's been changed by 1 note. But it's easier for me to say that there is a minor chord and there is a major chord, and there's a line of symmetry to show a relationship and a dynamic contrast that still ends up relating to the parent scale with regards to this line of symmetry. The line of symmetry is really important. So what other chords? If I go with the theory that says there's 4 chords, that says there's a major and then there's a minor. What else? That's a diminished. You see this right here from B to D to F. That would make a triangle, but I do the 4-note version. I include the G sharp. That's an equilateral shape. Let's play that. From B to D to F, and then add that G sharp. It's kind of a mellow, dark sound compared to the C major. Here's the C major. Here's the diminished. There's the A minor. The diminished would be, let's say the A minor would be the link, the missing link between the major and the diminished. If you go from the major to the diminished, it's kind of a drastic contrast. But if you go from the major to the minor to the diminished, it's a little softer transition. You know, you're not just going abruptly from and then to. You kind of get to go from. What's the other one? The other one is all.